In progress.
Welcome, everybody. Today we're looking at Unit 3. This is going to be one of those units that will extend over 2 weeks once again. There's just a lot of topics and concepts in here that we have to focus upon before we can really move forward with other materials. We are now reaching the point where, if you think back to our problem-solving unit, Unit X, where we were talking about the 3 methods for solving programming problems, and those were sequence, selection, and repetition. We're now moving on to the second approach, which is to select a path through your code, depending on whatever criteria you're working with in your program, whether it be numeric or user input or testing for something for true and false. In order to do that type of work, we really need to start by looking at how we do those comparisons. So like if you're going to reach a fork in the road, you have to decide, am I going left or right? If you, for example, maybe want to go have pizza for dinner tonight, and you want to order it from a restaurant, you might look in your pocket and say, if I have $20 or more, I will order out. If I have $20 or less, I'm going to make mac and cheese at home, for example. Well, in order to begin to make those decisions with code, we need to have some sort of mechanical operators in order to help us make those decisions. In essence, we are going to be testing for true and false, but we use basically comparison and logical operators that are shown on this particular page, and that's why I link here. So last week we learned about the mathematical operators. We learned about assignment operators for assigning values to variables. But then we get to the comparison operators where we test things to see if these conditions are happening or if they're true or false. So for example, if we're looking to see if something is equal to something else, and I think you guys will remember this because I mentioned it last week with the math operators. In fact, let's just go back up there for a second, where I told you, hey, folks, the equal sign is not the equal sign in programming. It's an assignment operator. It's a way to put a value into a variable. It has nothing to do with math. And remember the old adage, whatever's on the right side of the equal sign gets stored in the thing on the left, and the equal sign is not an equal sign. It's an assignment operator, try to pound that in your head. But if we do want to test to see if something is equivalent, we then use the double equal sign. And then that's actually a test to see, does, for example, X equal Y? And if X equals Y is true, then we take one course of action. Like I have $20 to order pizza. Or if it's not true, then we take the other path, right? So this is one way to test for true and false. We can also test to see if something is not equal, and notice the approach here using the exclamation sign in front of it. We can also check to see if a value is greater than or less than, or greater than or equal, or less than or equal, and pay special attention to these, especially if you're new to programming, how we don't write it like we do in math, where we put the greater than or less than sign over a single equal mark. That's not how we do it in programming. In programming, we use 2 characters together. That can also be combined with logical operators. So you can have one true-false test, and then you can have additional ones. So for example, I can test one condition to be true or false, and here's the keyword right there, and another condition to be true or false. So is X less than 5 and is X less than 10? And both of those would have to be true in order for the entire statement to resonate as true. With the OR operator, it's the converse. I'm looking to see if one of the 2 statements is true. They could both be true. That would be great. But if only one of them is true, then the whole statement registers as true. If none of them are true, then it registers as false. Whereas with the and, remember that both statements must be true. There's also the not statement, and normally that's used as a negation symbol. So you can have like a complicated statement or even a simple one, and you're actually looking for the opposite of it. So I don't want that to be true. I actually want it to be false. And sometimes it's easier to write your statements that way. So those are both the comparison operators and then the logical operators. Then that leads us to talking about the if statements, or the way that we make, the primary way that we make selections within Python coding. And we use the keyword if, elif, and else. And we're going to go through each one of those. But you'll notice right here at the top of this page how they start talking about Python conditions and how they're important to if statements. You know, for example, if I'm looking for a particular value, I might be looking for it to be equal, or I might be looking for it not to be equal to trigger some code, et cetera. And they go through the logical operators here again to kind of remind you, how, you know, the syntax and the verbiage. What drives which sign you use and what things you're comparing is completely dependent upon the situation within your program. It depends on what you're trying to accomplish, right? And so this might be a pathway through that you're selecting based upon other criteria in the program, you know, and the program itself and its solution will dictate what you're going to generate. When we start to use if statements inside of Python, we start with the if keyword. And I do want to kind of point out here that the if keyword triggers the statement, right? So in other words, I'm checking a condition for true and false. Is B greater than A? If it is, then it will output this code. I also want you to pay careful attention here to the fact that the statement that we're triggering is indented, and that preceding it on the previous line, there is a colon, right? And we'll run this one and I'll show you what happens, right? So obviously B is greater than A. So when we run this, it'll output B is greater than A. What happens though if I decide to make A bigger and then I run this code? Well, this is kind of interesting because basically it will do, I'm waiting for the, the event to drop here, and it seems to take forever. It'll basically do nothing because there is nothing, no code that follows, if you see what I mean. Another kind of interesting thing, if you wanted to do this again, just to prove that it's kind of skipping over that statement, you could run that, and if A is bigger than B, which is not true, this statement won't happen, right? That's indented. It's part of the if statement. However, after the if statement, there's a regular print statement and it says nothing happened. Okay, well, that's true in this situation, right? But if I switch this back to 33 and run it again, notice what happens now. It'll still say nothing happened because that's not part of the if statement. If you add statements underneath here, and you'll get to the point where you do that. So you'll add another statement, you'll add another statement, and notice how they're all indented. Those become part of the if block, if you will. All of them must be indented the same amount in order for them to be part of that statement. They only happen if this condition that we're checking is true. And that's really the important takeaway here. All right. So they go on and they start talking about indentation and how that's important. And notice that if you run this statement, and they're indicating here you will get an error, right? Because the if statement requires that after this colon, we have an indented line that follows, at least one, right? It can be many, but at least one. If I take my desired action that I want to happen with the if statement is true and put it at the margin, you will get an error message, right? So just be mindful of that. The code likely will not even run. All right, so let's say you check one condition, and then you need to check another condition in order to have your choice, right? So like, here's an example where A and B are set to the same value. So if I look at B and say, is B greater than A? Well, no, that's not true. They're the same. And if I had an equal sign in here, then it worked. But in this situation, it's not true. So this will not execute. However, if A and B are the same, and notice the weird syntax here, and this is especially weird for people that come from other languages. In other languages, what we typically do, and I just want to let you know, we usually do this, else if we use two separate words. to give an alternative test, basically. But in Python, we just say elif, which means else if A is equivalent to B, then we output the second block of code, which happens to be true. Right. From there, we start to look at the else statement, which is kind of like, okay, well, if this isn't true and that's not true, just go ahead and do this. Right. And you look at the logic that they're using here, and notice if B is greater than A, we're going to output B is greater than A. If they're the same, we're going to say they're equal. Well, what's the only other possibility after that? That A is greater than B, right? And it is totally logical. I don't have to test for it at that point. Be mindful of that, right? Because I've already eliminated two of the possibilities. So the last possibility is that it is greater. So that's an else statement. And sometimes you have these if statements and you're testing not one or two conditions, but maybe 10 conditions, maybe 20 conditions, and then you have an else. You can also do an if statement that skips the else if, so you can just go if, and if that's not true, just give it an else right out of the gate. You can do an if that's standalone. You can do an if with an else if, and then you can do if with the else if and the else. All of those are valid approaches. And here's an example of just an if and an else. There is also a shorthand way to do this, and this takes a little getting used to do this. My strong recommendation is use the method shown above most of the time. But programmers who get a little bit advanced with their skills, if they're just testing a single condition and there's no else involved, you can actually move that print statement up to the same line. So you're still running the if statement, you just move like what the result is up to the previous line and do it all at once. So if A is greater than B, we just print it. There is no else, there is no else if. If that condition isn't true, we just move on with the code. So that's a shorthand way to do it. There's also a shorthand way to do an else, right? And notice this one's pretty clever. So this one's a little weirder though, right? Because the if test is actually in the middle. So what we do is we say what we want the result of the true part of it to be at the beginning. Then we do the test. And then if that doesn't work, then we do this, right? And the objective of this syntax, right, in Python is to make it superhuman readable, right? So it says print A if A is greater than B. Otherwise, print B. You see, and it almost reads like you're speaking English. And I think this is a really bizarre approach. I tend not to use it, but I do see people using it, and it is very like conversational in its style. So it is kind of a cool approach. There are other techniques, right? And just by the way, this is known as a ternary operator or conditional expression, and it's kind of a weird approach, real frankly, but it is kind of a modern approach. And some programmers lean on it pretty heavily. You can kind of ramp that up, and you can also have multiple else statements on the same line. And I'm not really super much a fan of this. In terms of how my brain thinks, and maybe it's because I was traditionally taught programming, I like to see the indentations and the else's. It just helps me to keep it straight. When I look at this, I have a kind of a hard time reading through it. However, if you're comfortable with this approach, you can totally do it. So really, this is kind of like doing it like an if, else print, if, else print. And notice how it's just all in one line, right? And so I can have multiple else statements. In essence, is really what this does. Now, sometimes when we're testing conditions with if statements, we are going to use these keywords because sometimes we really are checking, two conditions. For example, let's go back to the pizza example, which I like to use a lot. If I have more than $20 in my pocket, so let's say that's the A is greater than B, and the pizza place is open, then I can order pizza. So both of those have to be true, right? I have to have enough money to do it, but the place also has to be open. And maybe it's like a Monday or a Tuesday and they're closed. And if one of these comes up false, then the if statement won't run. So this approach, right? And this is one to wrap your head around, is we're checking to see if this is true. Is A greater than B? It is. And is C greater than A? It is. Both are true, so the statement will execute. But what if I change one of them to not be true, right? So now is A greater than B? False. And is C greater than A? True. But one is false, so the whole statement fails. And then, of course, this would print nothing, and it's probably going to spin for a while. But that's, kind of how that works. So with ands, both sides of the statement have to be true. Conversely, if you use the keyword or and you're testing, two or more conditions, and I should add that, right? Like when you do ands or ors, you can test more than one condition, right? That can get pretty complicated to think about logically. So some people break it into separate statements, but it's totally feasible to do. So in this situation, we're looking to see if A is greater than B, which is true. And then we're also looking to see is A greater than C, which is false. But only one has to be true for the statement to run. So if I run this, what would happen? And I want you to kind of think about that in your head as I hit the button here. This is actually true, right? So A is greater than B, so that's true. A is not greater than C, that's false. But only one statement in an or must be true to get it all to run, right? So that you have different either or situations. And I'm trying to think of a pizza example here, and my brain's not doing it right now. So let's just move on. The other thing that you can do is if you're looking for the inverse operation. So like is A greater than B? It's certainly not in this example. But if I put the not keyword in front of it, it negates it or flips it, kind of like reverse logic. And so that would actually be true, right? A is not greater than B is kind of a way to read that. So those approaches are very helpful. Another thing that you can do is you can use what we call a nested if statement. And a nested if statement essentially allows you to place one if statement inside of another. And I want you to notice that when we do that, we are taking that if statement and starting it with the same indentation. And if I did not do that, then it would register as its own if statement, right? With its own if else. But it is possible, and once again, this is kind of a conceptual leap, to put an if statement inside of an if statement, inside of an if statement, and you can keep kind of going as deep as your brain logically can handle it, right? I tend to see most programmers kind of cap out at 3 or 4 levels deep, from a logic standpoint, just because their brain can't think through it. But these days with the help of AI, a lot of them are going deeper than that. But basically the point is, in order to ever get to this if statement, you have to first trigger this true, right? So like, is X greater than 10? And in this case it is. So it would print above 10. Then it would check again. Is X greater than 20? All right. And also above 20, right? And if it wasn't, it would print out this, but not above 20, right? And you can work with that. Another really common thing to do is if you're building an if statement and you haven't figured out what stuff you're putting inside of it yet, you can throw in the pass keyword that allows you to skip the code and not generate an error. Because normally if I had an if statement and I didn't have anything underneath it, it would error out and say, hey, where's the rest of this, right? If you're still in the process of kind of conceptualizing it, you can throw in a pass statement, or maybe you're in the process of building all the other statements within it. You can throw in the pass statement, and this pass statement works in other structures as well. But I think it's a very helpful one when you're just kind of sketching out the logic of your code and you're not sure what goes where yet. So that's a nice one to know. Another important concept here is the match statement. And for those of you that have learned other languages, I do this as a basis of comparison. And the real easy ones to compare to are Java and C# and C style languages, where they have case switch statements. Ironically, and I thought this was really weird, that Python didn't have this structure until version 3.9. It was introduced in version 3.9. We're on 3.12 or 1.3 right now. Um, and here's the situation. If you have a situation where you're writing a significant number of if, else if, like you got like 20 scenarios or something you're checking, and I don't know like what point I start to switch over, maybe around like 5 or 10 else ifs, I might switch over to what we call the match case statement, which looks basically like this. So you still have some sort of an expression that you're analyzing. And really, in this case, you're not checking, and I want you to be careful about this. Um, the expression can be in various formats, but generally we're grabbing a value, and maybe it's from the user, right? Like they typed in a name or a state or a number or something. And then we take that value and we search for it in our if, well, these aren't ifs, right? For the case statements. And then depending on if there's a match, then we go ahead and execute the code within it, right? So I'll give you an example. So it says here, we have a value for day, which equals 4. Then notice there's no greater than, less than, ands, ors, nots, or anything like that here. This is just, I'm checking day. So if somebody enters like the number 4, I try to match it up. Is it 1? Nope. Is it 2? Nope. Is it 3? Nope. Is it 4? Yes. So I would print Thursday, right? None of these others would execute. We're checking the case, but here's the weird thing about these, right? So if this one hits, it'll still keep checking the rest of them. And so maybe it's not as quite as efficient in some ways, but if you could imagine, let's say you have a person like, what state do you live in, right? And there's 50 options or whatever. Would you want to write else ifs, or would this be easier? And the answer is, yeah, this is easier. There's also a thing where we can add a default value, and I want you to notice here that if none of the values catch, and in this case 4 would not catch, we put in the underscore, and then we would put something on the screen basically that responds to any scenario that doesn't catch above. And in this case, it would always hit the default value, right? And they make the point here, that one will always match regardless of what you throw in, right? So if you threw in a 6, it would say today is Saturday, and then it would also say looking forward to the weekend, right? But the practice here, and this is true in other languages too, is you put it last if you're expecting it to catch every time. You can combine values in these statements, and notice that they use the pipe operator, and that's right above your enter key is the shift of the backslash key. So you can check for several different values and have it all respond with the same code. So that's a thing that you can do. And then you can also use if statements within your case statements, if you wish. And I'd say this is a little bit more of an advanced technique, but not really that hard. Not something I see very often, but people do use that approach. All right, so those are the match statements.
Recording in progress.
All right, so we're going to move on now. We've covered all of these topics already. And of course, when we do our coding, we'll kind of demonstrate how it all works, and the scenarios kind of drive all that. We'll also talk about techniques for testing your programs to make sure that they're working correctly. And a lot of that is just in the write the code, try it. Is it working the way you expected, right? So once again, I'm going to cover that more in the exercises. I do want to look a little bit more at some string concepts here before I wrap up this lecture. So I'm going to take us to their page on strings here, and I'm going to copy that address and go back over to my Brave browser here and take us to this. So this is something we've already kind of lectured on and learned about, right? Like we know what a string is. You can put double quotes around it or single quotes around it, and we've been printing them right from the get-go, right? One thing that you might want to consider, though, is like, why do we allow for both double and single quotes? And I think we talked about this, right? Where we, if you wanted to print a single quote inside of a string, you have to have double quotes on the outside. Here's an example of like Johnny being that way. Or if you want double quotes on the inside of a string, then you need single quotes on the outside. And those are techniques that you kind of figure out as you go along. You can put a string in a variable. And remember, Python doesn't care what you throw in a variable, what strings go in there. And then eventually you start to figure out, like, oh, gosh, it's really such a pain when I have like a string that's super, super long, or it's multiple paragraphs, or if you guys were doing like poetry or songs or whatever, like in that one assignment, there is a way where you can use either 3 double quotes or 3 single quotes to have whole multi-line strings. That's entirely possible to do, right? So not something we use significantly, but it depends on what you're doing, obviously. Here's a concept that we're going to learn about going forward, because our sequence here is we first learned about sequential programming. Now we're learning about conditional or selection programming. Then we start to learn about loops, and then we start to look at data structures. And one of the first data structures that we learn about is the thing called a list, a.k.a. array, right? Which, and this is a little bit deeper concept, and really what I normally tell people is when we get to the list, chapter or whatever, or unit is a better word, we really kind of dig in a lot more deeply as to what this stuff all means. But we have an assignment or two in this chapter that kind of utilizes this concept. So I think it's important to kind of break it down a little bit to explain. Strings really are a collection of characters, and I'm looking at hello world here. So like there's an H and an E and an L and an O and a comma and a space, and that's a character too, by the way, and then more letters and a special character. But each one of these is really an individual entity, right? And their collective existence within this structure makes it a string. And really what string stands for is a collection of characters or an array of characters. The interesting thing about string structures is I can address each individual character separately in the string. And Python is super elegant at doing this compared to other languages, in my opinion. Like, for example, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 characters in this string. And we can number them. So in other words, if I want to just extract that capital H, that would be, and mind you, in position 0. Computer code always starts counting at 0, not 1, folks. So when I have this print command down here, and I want you to notice the square brackets, I can take the variable, which contains a string of 13 characters, and I just want to print the second letter. I put the variable name, square brackets, and the number 1, remembering that the first letter is in position 0 and the second letter is in position 1, etc. So the last letter is in position 12, right? If you catch my drift. So if I were to print this, it would only print this lowercase e, right? So this is important for one of the assignments, which is why I bring this up. There's also the string length function. This is one that's going to come up in our assignment, because if you're going to, let's say, try to print a certain character in the string or analyze a certain character in a string, it's helpful to know how long that string is. So if I took my hello world and ran the length function around it, right? So I take the variable and stick it in the parentheses, it will tell me how long that string is. It'll say it's X number of characters. And so you can run that to check it. And I would do that if I were you. Another thing that's kind of an interesting keyword is the in keyword, right? So here we have the string, says the best things in life are free. And then we are here basically checking to see, is free inside that text? And of course it is, so it would work, right? If we ran that as an if statement, and this is really kind of interesting, if free is inside that block or that string of text, then print this line. And indeed it is. And I'm not going to demonstrate that. You guys can do that on your own. And there's also the converse, right? So if you're looking for expensive, if expensive is not in text, right? And they have it as an if example as well. I'm not super worried about these last two, obviously, but I just like to put it on your radar as being kind of helpful. Another thing that we want to look at is a couple of functions here related to strings that we're going to use in the exercises. One is the lowercase, and then the kind of the complementary uppercase. And it doesn't matter which one we look at really, but this is really kind of a common issue, like especially when you're interacting with a user. So like if a user, says, what do you want for dinner? Pizza or burgers, right? But you don't want to write code that tests for every possible upper lowercase combination. You can take the text and then you add this method, and notice how a method, works a little bit differently than a function, where I'm not putting it inside the parentheses. I'm just adding this dot syntax. So I'm saying that this variable, let's run this string method on it and convert it all to uppercase. I will run that one so you can see that if I do that, it converts everything to uppercase. Now, if you're checking that text, then I don't know, for example, like to see if it's a password, or whatever, or maybe that's not a good example, but to see if it's the word you're looking for, it's a lot easier to check it if it's all one case. So a lot of times programmers will convert everything to lowercase or everything to uppercase to keep from having to test every possible upper lowercase combination of letters. So that's really kind of the functional reason why we take a look at that. I think that covers all the topics I wanted to hit upon here. Of course, we are using user input in this unit, and we already have been doing this, including inputting numbers and then taking numbers and converting them to different formats. So this is something you can read up on. I just put a link in here because I realized last week I didn't do that. And folks, this video ends here. That's our lecture material for this unit. And I would also implore you to look at the old lecture videos that are recorded based on our textbook, or I talk about a few other topics as well. But this is really sufficient right now for completing the work in this chapter. So that wraps this video. And I wanted to put my my homepage back up here, but hey, it is what it is. We'll see you in the next one. Take care.